This is section 5.5, integer exponents and the quotient rule. Integer exponents is a fancy way of saying negative exponents, basically. We're going to have positive and negative exponents to worry about now. And our rule for that are these two, basically. Here's the thing you need to know about negative exponents. They don't make the number negative. They literally just flip the place in the fraction where they are. So for example, a to the minus n, this is going to go to the denominator and become a to the positive n. Similarly, if you have a to the minus n in the denominator, it comes up to the numerator and becomes a to the positive n. So all negative exponents do is they switch places in the fraction and they become positive exponents, and then you deal with them from there. For the quotient rule, that's going to tell us how to deal with a to the m over a to the n, and it's pretty simple. We're just going to subtract top power minus the bottom power. This will become a to the m minus n. This is very much like the product rule, right? Remember, the product rule says if you're multiplying things like this, you would add the exponents. This is saying if you're dividing them, you subtract the exponents. So it kind of follows from the product rule. Let's talk about our negative exponents first. 2 to the negative 3, like we said, this is going to drop us down in the denominator. It's just going to change places and become 2 to the positive 3. Now we know what 2 to the 3 is, though it's 8, so our final answer should just be 1/8. That's how you deal with it. Notice it did not make the number negative. Here we have a negative exponent, so we can drop it down the denominator, 1 over x squared to the 4th. Now it's positive, right? And then we'll use that power to a power rule. This will be 1 over x to the 8th. Remember, when there's power outside the parentheses, you multiply them. Lastly, I want to remind you, exponents only apply to what they're right next to. So this 3 has nothing to do with that. So only the x to the negative 5th is going to move to the denominator and become x to the positive 5th. This will look like this, 3 over x to the positive 5. Nothing else we can combine there, so that's our answer. Here we are multiplying some pieces with positive and negative exponents, so I'm going to go ahead and, instead of fixing them, like dropping this down, let's just multiply these together and add our exponents. This 2 is along for the ride. For our x's, though, we have 2 plus negative 5. 2 plus negative 5 is actually a negative 3. And then again, our final answer should never have negative exponents, so we're going to drop that down in the denominator and make it x to the positive 3. Don't forget, this 2 is not affected by that. That's why the 2 stays up here. Only this piece goes to the bottom. Similarly, down here, we're going to start with the power to a power rule. Don't forget, all these pieces without exponents have a 1, because what I'm going to start with is taking the power on the outside and multiplying it by all the exponents. Take the power multiplied by the exponents. So our first step is going to look like this. We have a to the minus 3, b to the minus 3, and then we have a to the minus 6, right? This is the piece where we're taking the minus 2 times the 3. And then we have b to the 3. Okay. Now let's, so we dealt with all of our exponents on the outside. Now let's combine all of our a's. A to the minus 3, a to the minus 6, that'll give us a to the minus 9, right? We're adding those powers. B to the minus 3 and b to the 3, negative 3 plus 3 will actually give us 0, so we get b to the 0. Almost done. B to the 0 is just 1, so that's just going to become 1. A to the minus 9 is going to go in the denominator and become a to the positive 9. So this whole kind of nasty expression that we started with actually simplifies to something pretty simple, 1 over a to the 9th. Now the quotient rule, whenever you're dividing the same base with the exponents, you subtract the exponents, top minus the bottom. So this will become 5 to the 6 minus 4, which is obviously 5 to the 2nd, which we know is 25. Okay, so top power minus the bottom one. Now here we have some numbers, some a's, some b's. Do them all separately. So 6 over 2 is 3. That part's done. The a's, you get a to the 7 minus 3. I'm actually going to write that step in for you. It's a minus. And for the b's, you get b to the 1 minus 2. Don't forget there's a 1 there, and don't forget it's always top power minus the bottom. That's important because we're going to end up with a negative exponent here. Okay, so we have 3a to the 4th, that's 7 minus 3, and b to the negative 1, that's 1 minus 2. Our final answer, that b to the negative 1 has to go to the denominator. 3a to the 4th all over b. We don't actually need the positive 1 because we don't need to write the 1's. That is our answer. Lastly, we need to talk about some scientific notation. This is the way in science that we represent really large or really small numbers without writing tons of zeros. So the key to scientific notation, though, is you have some number, some decimal typically, times a power of 10, 10 to some power. Now this number, though, it's very important that the decimal point, there can only be one number to the left of the decimal point, one non-zero number. So like 5.23 can't be 52.3, has to be 5.23. Same thing here, 8.1, only one number to the left. So these are already in scientific notation. I'm going to tell you how to write them outside of scientific notation. Start with your number, 5.23. Now our power of 10, 10 to the fourth, a positive 4, means we're actually just going to take the decimal and move it 4 times to the right. So that'll be like this, 1, 2, 3, 4. It's going to, notice there are zeros over here, right? So our answer is going to be 52300. Now the decimal point's over there on the right, and I'll put in our comma. That's actually the number 52,300. It's not terribly big, but that's how it works. Okay, similarly for the second example, this time we have a -3 power. Negative means we're going to move it to the left 3 times, right? So positive 4, 4 to the right, -3, 3 to the left. Take your 8.1, take the decimal, move it 3 times to the left. 1, 2, 3. These are zeros. The decimal point's in front now, so our answer will be 0.0081. Now we're going to practice putting some numbers into scientific notation. I want to remind you, the important part is where you put the decimal point. So for our top example, we can kind of ignore these zeros for now. We're focusing on the numbers, 38, 3 and 8. We're going to write this as 3.8. We can only have one number to the left of the decimal. So we'll start out with 3.8 times 10, and we have to figure out what the power is. So the question you're asking yourself now is, if I put the decimal point here, how many times do I have to move it to get it back to where it started, right? Originally the decimal point was over here. Well, if you put it here, you'd have to move it 1, 2, 3, 4, 5, 6 times to the right. What do we do with 6 times to the right? We call that a positive 6. There we go. Scientific notation for that number. Same thing with this second example. Focus on your numbers first, 581. We're going to put the decimal right here, 5.81. And now imagine the decimals here. What do you have to do to it to get it back to where it originally was? Well, we would have to move it 1, 2, 3, 4, 5, 6 times to the left. 6 to the left means 10 to the minus 6. There it is in scientific notation. Last example, 251, we're going to make that 2.51. If it was here, how many times do we have to move it to get it all the way back here? Let's see, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times to the right. That's going to be a positive 11, so 10 to the 11th power. There we go. That is section 5.5. Let me know if you have any questions. Keep up the good work.